Today we're going to continue with area, but now we're actually going to be looking at the area of circles. So we're going to be using still the radius and diameter of the circle to do this calculation. And we're going to discover the formula to find the area of a circle today as well. The first thing I'm going to try to explain to you is where this formula comes from. If you think back to when we did circumference of a circle, remember that formula we were using was representing the relationship between the diameter of a circle and its circumference, that proportional relationship. And remember, pi was that constant of proportionality. Now, for the area of a circle, this image here is going to help explain what I'm trying to show you. So, first things first, to find the circumference of a circle, remember we would multiply pi times diameter. Now, another way to do that, and a way that we didn't talk often about, but I think it'll make sense when I show you, is that we can also find the circumference of a circle if we take 2 pi times radius. Now, think about that for just a second. So we would always find the diameter of the circle. Remember, that's the distance across the circle here, from one edge to the other through the center point. So we would find the diameter and we would multiply by our constant of proportionality to get the circumference. If we look at it this way, what we're doing is we're taking our constant of proportionality times the radius, which would be half of the diameter, and then we just need to take 2 of those so that we can get the full distance across the circle and the full circumference. Now that's important because today what we're going to talk about is what half of the circumference would look like. And if I change this equation just a little bit, so now if I want half of the circumference of the circle, so only going around half of this circle here, then I wouldn't need 2 times pi times r, but instead only 1 pi times r. All right, now keep that in mind as we keep going here. So if we look at this shape here, it almost looks like a parallelogram if you can look at the outline here. The only difference is this edge is just kind of slightly bumpy. But all of these wedge shapes, all these pizza slices, come from the circle here. It's just been separated, it's been cut apart. So you can see we had 4 blue sections, which are here, and 4 red sections, which are here. And then the same with the yellow and green across the bottom, but they're all sawtooth to one another like shark's teeth, put together and forming this shape that's very similar to a parallelogram. And if you'll remember in our last lesson, when we were looking at the area of shapes, what we were doing was taking the measurement of the length times the height, and that height was the distance between these 2 perpendicular sides here, and that would tell us the area. It's the same idea as how we find the area of a rectangle. We'd multiply the length times the width, or the base times the height. So whether we call this base or length, whether we call this height or width is not important. We just need to multiply these 2 measurements to get the area of the shape. Now let's see where those measurements come from on our circle. So here we put all the edges of the blue, red, all together to make up this side length, and all of the yellows and greens to make up this side length. Well, you can see by the color coding that all the greens and yellows together make up half of the circumference, because these little curved edges here are the outside curved edges of our circle. Now we could cut these slices even smaller and get even smaller of a curve along this outside edge so that it would almost look like a straight line. But regardless, it's going to work. These curved edges all together make up half of our circumference. And remember, we said we can find half the circumference by multiplying pi times r. So this here is pi times r times the radius. Now let's look at the height of this figure, the width of this figure. It goes from the tip of the slice to the center of the edge here. Now if we look here on our circle, that would be the radius of the circle. So the height of this figure is equal to the radius. Now, here's the cool part. Here's where our formula for the area of a circle comes from. Remember, if this was a parallelogram or a rectangle, we would just multiply these two measurements. So pi times radius is this one dimension. Radius is the other dimension. So our formula for the area of a circle is going to be pi times radius times radius. And I'll write that here. Pi times radius times radius. Now, because we're talking about the same circle, we are talking about the same radius here. And whenever we multiply the same number by itself, we can use exponents. So another way to write the area of the circle is pi times radius squared. And I don't need to put a multiplication sign there if I don't want to. Okay, but the radius squared is the same as radius times radius. And this is the formula that we're going to be using for much of our problem solving today. Let's look on your handout at the first couple of examples here in the table, and then I'd like you to try the rest using the formula that we talked about. So don't forget, the area of a circle is pi times radius, or pi times radius squared. So when we were finding circumference in the first 5 or 6 lessons, we needed to know the diameter of the circle. Now we're working the other way, and we want to know the radius. Here it's already identified it for us in problem number 1. So all I'm going to do is take my formula. Again, for most of these examples, we're going to round pi to 3.14. And then I need to multiply that by my radius squared. So multiplying by 14 squared, or 14 times 14. Okay, all I'm going to do is that math. On a calculator, if I don't want to find the exponent button here, the square button, I'm just going to type in, because the order for multiplication isn't important, I'm going to type in 3.14 times 14 times 14 to get what my area for the circle would be. It also tells us to round our answer to the nearest tenth. So please make sure you're doing that, and you should get 615.4. Now this is an area, so we need to give an area measurement. Area is always measured in 2 dimensions. So we're measuring in meters by meters. So square meters is what we're measuring the circle in. And so we're going to label it as square meters. Okay? For the next example, we have, and this is what you're going to have to be really careful of, this is the diameter. The diameter of the circle is 20 centimeters. I only want the radius, which is from the center of the circle to the outside edge. It's going to be half the diameter. So I want to take half of that to get my radius of 10. And then when I complete the formula here, 3.14 times 10 squared, or 10 times 10. 10 times 10 is 100. So really, this can be done without a calculator because we're multiplying 3.14 times 100, which is going to give me an area of 314. We've got a different measurement unit here, centimeters, so I'm going to have square centimeters because I'm measuring area. All right, let's look at the bottom of your handout. And question 7 says a circular lollipop has a radius of 1.5 inches. It's given us the radius. That's good. That's what we need for area. What's the area of the lollipop to the nearest hundredth of a square inch? And it tells us to use 3.14. Okay? Let's use our formula. Area equals pi times radius squared. I'm going to use 3.14 for pi. I'm given the radius in the problem, so that's 1.5 squared, radius squared. And when I do that math of 3.14 times 1.5 times 1.5, I get, let's see, let me write it over here, 7.065. Now, this is not the case for this problem because our answers are far enough apart that I don't really have to worry about rounding my answer. But I have seen some people having trouble with rounding. So please remember how we round numbers. If we have to round our answer to the nearest hundredth, that means my answer must stop at the second place value, the hundredths place. Okay, now you hear the term, do we round down or round up? What that's really asking is what's the nearest hundredth that this number is closest to? So if I were to drop off the ending of this decimal, this would be closest to 7 and 6 hundredths, 7.06. But if I were to go up to the next largest hundredth, that would be 7.07. And I'm going to use this next decimal place to decide what I'm closest to. Now, fives are always halfway between in our number system because we have a base 10 number system. And here's the rule for rounding. If we are at least halfway between the two numbers, we're going to round up. If this number was 4 or less, then we're closer to this number and we would round down. All right, in this case, we'd round up to 7.07, and that is our answer choice there. For 8, it says the circumference of a plate is about 41 inches. Circumference of a plate. What is the approximate, so we can estimate our answer here. What is the approximate area of the plate? Now, here's the tricky part. We're given circumference. So we've got to solve this puzzle. We've got to work backwards to get what we need in order to find the area. And remember, area uses the radius of the circle. So let's back up. Circumference is pi times diameter. If the circumference is 41 inches, and we use 3.14 for pi, what is my diameter? I need to work backwards here, so I need to divide. I'm going to divide 41 by 3.14. So we'll divide by 3.14, which will tell me what the diameter is. And the diameter of this circle is 13.06. And I believe that had to be rounded. So 2 decimal places is enough for what we're doing here for our math. We're finding the approximate area, so we don't have to be precise here. All right, so I have the diameter of the circle. I need the radius. Remember, the radius is half of the diameter. So let's take our diameter of 13.06 and get half of it so that we have the radius, 6.53 inches. Remember, that's the radius. All right, now we're just going to put that into our formula for area. We're going to multiply the radius by itself, or square it, and multiply by pi, 3.14. That gives us an answer that is closest to 133 squared inches. All right, turn in your handout to the back side of this sheet, where you're going to have a little more practice. I'm going to do the first one for you, just as another demonstration, and then I would like you to look at the rest. I would say first thing at the top of this paper, though, is write down the formula for area. And in this case, we're finding area and circumference. So let's write both of those down. Circumference is pi. Let's do 3.14 because that's all our calculations are going to be today. 3.14 times diameter. And area, let me do a different color, is 3.14 times the radius squared. So to start, let's find the radius and the diameter of the circle. Well, I can see labeled here for us all the way across the circle is 8 feet. So that is going to be our diameter. The radius is half of that, which would be 4 feet. So the radius would be from the center point to the outside edge, just half the diameter. And we're going to use one of those to find the circumference and one of those to find the area. First, let's find the circumference. So we'll take 3.14 times the diameter of the circle, which is 8. If we do that calculation, the circumference is 25.12. To find area, we'll take 3.14 times 4 times 4. Remember, that's 4 squared. 4 to the second power is 4 times 4 is 16. And I'm going to take 16 times 3.14 to get the area of 50.24. And this is area. This is going to be square feet. So I could write it that way, or I could just write the words square feet. Either one would be a fine label. Now the circumference, remember, is just talking about a distance. That's still able to be labeled in feet, just like the radius and diameter that were another distance that was measured. Okay? For your answers to all these questions, rounding to the hundredths place is enough for what we need here. Please don't write down the whole long decimal that your calculator gives you, but do remember to round it. So if that third decimal place, that third digit in the decimals place is 5 or more, round it up to the next hundredth. If it's 4 or less, just round it down to what it would be without the remaining digits. Okay? I'll be on Zoom to answer any questions. Please look at the notes for the answers to the problems that I didn't go over so you can check. And any questions we can certainly talk about and get straightened out. Have a great day.